So as you can see, we have like one launch command. It basically launches everything. Launches the always raw image and gazebo. As you see, first the gazebo sim launches, followed by always and image raw. So now always has launched. As soon as the always launches, basically the mission starts. As you can see, this is the always sim mission, the image raw, and this is the world environment. So yeah, as you can see, so they're coming to the robot. So for the robot base, I've used waivers like STL files for the base. So and for the arm, I've used AL5D's 3D of arm, and face and the torso is custom made. As you can see, you have the Drifts logo on the face. Now it's performing the pick action. So for the first mission, so mission is divided into 4 different parts. It's like a basic waypoint to waypoint hard-coded mission. So it has like the pick 4 different functions that work. Pick function done by IMU. So once so the pick function, so what it uses like a proportional approach, like a control block, like, and basically uh, stops at 0.7 meters from like the object. Um, and like the turn by basically rotates the robot 180 degrees, and then they have also included a proportional like micro correction uh, logic here, so that uh, whatever be the angular velocity, it should not like overshoot. So once the IMU reading reaches 1.57 radians, which is like 180 degrees, it starts like heading in like these direction. So you can see here. Uh, so once it reaches 1.5708, it basically starts moving ahead. Sorry, yeah, it's target reached and then it's starting to move ahead. So it has 2 sensors on board, 2 working sensors, as you've seen in RBs as well as the raw image. So for the first mission, this is a purely uh, uh, waypoint-based mission. Second mission is the block 2 mission, where we'll be picking up 2 objects, so toy block 2 and toy block 3. Uh, so implemented like a full buck 2 planner. So again, this is the fourth stage of this mission one. So again, it basically rotates 90 degrees, corrects itself, like makes it like perpendicular, and then the arm drops the object uh, into the box. So once it does that, basically the robot for the second mission starts. It aligns itself perpendicular to the toy block and starts moving in a straight line. And if it encounters a wall, it basically buck to algorithm comes into place and basically starts wall following. And yeah, so if there aren't any walls, it like breaks out of that function. Again, aligns itself perpendicular to the waypoint, second waypoint, uh, and then charges ahead. So you can see basically the dropping object drops the object in the box. Perfect. And for the world, uh, so I've used multiple STL and DAU files, Polada files for assets. Like so, I've included that in my Apple document as well as the GitHub the README, like links to the all the sources. So the room 1 is basically the kitchen and dining area. So I couldn't find fridge and kitchen tops. So basically these are custom made. Rest all are uh, assets that I could find online. Sofa, bookshelf, chairs. I mean, all the chairs are same source. Table and this as well. The TV cabinet was also custom made. It's just a block. So as you can see, the robot is aligning itself. So the second waypoint is here over here. it basically aligns itself in a straight line to this particular point. And once the point, so I've kept the threshold value very low so that there are no uh, errors. Like, so I think I put the threshold value up to like 0.01 radians, which is basically next to negligible. So yeah, so mission two is basically bug two. Mission three, for mission three, the objects that I've put on the ground is a ball, a cylinder, and a cone. So that has not been implemented yet, but like I want to include like a computer vision aspect into uh, navigation. So basically random exploration, and whenever it encounters, so but I'll have to train like a model to detect the shape of those objects. So I've taken like multiple like virtual pictures in Gazebo itself, and train to train three different like train a model to detect like these three classes of objects, and so that'll be um, a random exploration based algorithm. Uh, and once it detects any one of these objects, basically comes towards it without any actual waypoint feedback or odom feedback, and goes and picks up the object. So I haven't, so that has not been implemented, but I want to like in the future I want to implement that particular algorithm in this particular project. So now, as you can see, it's approaching the wall, and now I'll stop. You can see in ours as well. The wall following is started. The bug 2 implementation was a little slow uh, because I did not want overshoots. So like I kept the angular velocity, everything, and like bug 2 following velocity is also a little slowly. And, and what else? No progress seconds. So I think I can reduce that. That is so that I can change that to 5 seconds. It's at 10 seconds right now. So maybe if I change that, it'll the the speed will increase, the time taken will be reduced. So now, as you can see, it's basically following the wall. Now I'll reach the breakout point. Once it reaches the breaking point, it basically stops following the wall and aligns itself to the waypoint. So the waypoint is right in front. So, but I think I need to reduce the angular velocity because there's a lot of skidding that is happening. In the document mentioned, you mentioned like there's that will not be graded on the navigation aspect of it, but um, I thought at least Like if it, I mean it's so like one aspect of the document that I think I was not able to satisfy was the runtime should be under 5 minutes. Uh, I don't think that I'm able to, like, for all the objects, of course. But I mean, if you're only considering one object, then I think I was well within the time. Uh, so yeah, yeah, and this is also one bug I was not able to figure out what the exact reason was for this distance that you see here. So whenever the magnet switches on, uh, it probably has to do with SDF file of uh, the the object. I'll have to figure that out. Hopefully. But otherwise, yeah, all in all, this will be my final or pre-final submission for this particular project. And yeah, I think the document also mentioned that the robot must spawn exactly uh, on the surface. There shouldn't be any overlap. So I have taken care of that as well. So when you launch the home.launch, uh, uh, so you'll find that there are no, like, I've seen in like multiple simulations that usually the wheels and the surface are, like, the merge, basically the spawn inside the surface. So, and I've bumped to that problem as well in few of my previous projects. uh, so I took care of that. It's now aligning itself to the drop point, drop xy, and now I'll encounter this wall again, the same sequence of wall following and correction, and then I'll go into the drop point. And yeah, I think it's been more than 5 minutes already, so I'm gonna stop the recording here. But then this sequence also works, so I just wanted to let you know. So yeah, thank you.